Chapter 1 Project Title Introductions. The retaining wall is a building erected especially for support or hold land vertically so that the land is not collapsed. To avoid this, the retaining wall ruin shall be constructed with a proper update so that it does not fail, and which work will some factor should be taken into account in terms of going on ground that is not the same level. Whether the land was cut or added in a drain in order to avoid going on the ruins at officer and at the surface of the land, steps such as cutting the hills to building the roads. Foundation is the part of structure which transmits loads directly to the underlying soil or rock. This causes foundations play an important role as the interface between the load-carrying components of the structure to the ground. Foundation elements especially considered include shallow foundation such as footing and mats, and deep foundation such as a driven pipe and drilled shaft or caissons. Site investigations is covered as an integral part of designing any foundations. In general, there are two categories of foundation. First, shallow foundations and deep foundations.
This is the site layout. The title project is Interchange 4 of Project B11 Road Upgrading Work in Jalan Indah, Melaka. Scope of work: to identify the type and parameters of land and the surface of the soil at the project site, to identify the suitability of the basic size required, to ensure that all proposals and arrangement is accurate and in accordance with the technical requirement, soil strata, thickness, length and width of each layer, groundwater table, location of rock layer and rock condition, sample for laboratory testing.
Geo Consult Sdn Bhd is a civil and structural consultancy that has been long established and is a strong company led by Mr. Muhammad Safwan bin Naziwan as a chairman of the company with the help of the associate, experienced engineer and consultant who are responsible in handling and managing the project as a dedicated team. Mr. Muhammad Hawari bin Muhammad Ali and Mr. Cairul Anwar bin Mazin as our site investigation. Interpretation engineer Mr. Muhammad Nur Luqman bin Muhammad Zamani are responsible for the foundation design, and Mr. Lim Boon Kiat responsible for the computer programming on the foundation and concrete design. Our lab department is led by Mrs. Noraida Hanim binti Jamal and Mr. Wan Ghazali bin Wan Yusof. For the quantity surveyor and finances department, our company appoint Mrs. Nurul Shahira binti Yusof as head of financings. Lastly, Mr. Ahmad Farhan bin Cik Roslan acts as a managing director.
For Chapter 3, personnel responsible for site investigation, which is known as SI. Soil investigation, which is the site investigation, is consistent of several activities that we must perform according in order to obtain adequate information for foundation design as well as for feasibility study of the purpose of the project. On top of that, we have subsurface condition, which is based on borehole information provided. In the subsoil condition, within the project site classified, and then we have groundwater condition, which is measure made in the borehole during site investigation, indicate that the groundwater level is about 2.62 meter below ground level.
Today I would like to present about subsurface condition. Soil condition based on the borehole information provided, the subsoil condition beneath the project site classified as follows: very soft to soft clay, grayish silty sandy clay with appreciable amount of fine sand. Very soft to firm clay, this layer was found underlying the soft clay. It is a light grey to grayish silty sandy clay. medium dense to dense sand. This layer was found in it is light grey, silty clay sand with some gravel. Its thickness range from 1.5 to 57 meters. Dense to very dense silt. This layer is found at depth above the bedrock level. It is yellowish red to light grey, mottled brownish yellow, and contains an appreciable amount of sand and gravel. The last one is granite bedrock. This coarse-grained intrusive igneous rock is found at depth 72 to 73.5 meters. It is generally fresh with an accuracy of 60%.
Assalamualaikum and very good day to all of you. My name is Nurul Shahira binti Yusuf. I would like to continue to present the chapter 5 is about foundation and retaining structure design. In this proposal of design, three aspects of geotechnical that we could take up. The first one is shallow foundation. Second is deep foundation, and third, retaining wall structure. Now, I would like to compare the main of the foundation is which are shallow versus deep foundation. The shallow foundations are commonly used for smaller projects and when the top layer of soil can adequately handle the distribution of weight, while deep foundations transfer the load from the top to down to a layer of substrata, bedrock, to ensure structural integrity. I would like to continue about retaining wall structure. Here we can see parts of cantilever retaining wall. We start from the top, is backfill, stem, base slab, heel and toe. The design of retaining structures should be taken into account among others. Wall should be designed to resist the maximum lateral pressure, that is the rest earth pressure. I also put up the 3D of the cantilever concrete retaining wall. Here we can see the turfing and then the gravel layer for the red one and grey is backfill, compacted backfill, and the bottom one is undisturbed soil.
Chapter 6. Discussion on field and laboratory tests. Discussion on field is to establish horizontal ground control, to establish high control from government benchmark, to carry out detailed survey with specification required by the client, to carry out cross-section survey at requested area, to pick up all the soil investigation points, to provide the drawing in AutoCAD format. Laboratory tests: boring, standard penetration test (SPT), soil sampling, rock coring, laboratory testing, consolidated undrained (CIU) test, unSI compression test (UCT), unconsolidated undrained (UU) test, and lastly compaction test.
Safe bearing capacity. Safe bearing capacity as shown in the table. Method of reducing negative skin friction. The effect of negative skin friction can be eliminated by sleeving the pile section within the overlaying field or soft clay. Alternatively, it may be surrounded by a plastic membrane with a low friction value or coated with bitumen. If bitumen is used, care must be taken to control the application to ensure that the coating adheres properly to the pile and is at least 3 mm thick.
I will explain on the pile design depending due to calculation project. For calculation of pile design, our team project was choose 10 span pile type precast prestressed concrete pile with a diameter of 0.5 meter for each pile with spacing of 3.5 D to transfer 8,000 kN load from the ridge to the beneath of the hard layer of soil with a safety factor of 2.5.
Chapter 9: Conclusions and Recommendations. As a conclusion, in this project, piles foundation designs was chosen to transfer the loads from structure to the hard strata, rock or soil with high bearing capacity. The piles support the structure by remaining solidity placed in the soil. As a pile foundations are set in the soil, they are more tolerant to erosions and scour.